Machine learning is drastically changing the world for the better or for the worse. I can give you some reasons why you should actually become familiar with machine learning and actually where to begin. Machine learning is so embedded in our lives, it's not going to go away. It's only going to become stronger. Although machine learning or artificial intelligence sort of has a bad connotation with it, with all the pop culture and all the films that we have been watching, artificial intelligence and machine learning is incredibly cool, especially if we understand or have some understanding of the inner workings behind how each of these algorithms operate. And so the more we understand about such a process, the less fear that we have. And so that's where I come in. So you're interested in machine learning or artificial intelligence, but you don't know really where to start. Well, look no further, because I'll provide you an overall roadmap as to what algorithms you should focus on first in order to build your foundational understanding, and then you can go from there. Based on my previous experiences as a working data scientist and a data engineer, I'll help demystify the vast data science industry altogether and help break it down into very small bite-sized pieces for you to understand. Almost everything around us is powered by machine learning. For instance, how did this video even appear on your page? YouTube has an incredible, powerful recommendation algorithm based on your search history, popularity of this video, watch time, likes, comments, and a variety of other features. YouTube is algorithmically optimizing the amount of time you spend on its platform. And talking about the YouTube algorithm, make sure you hit that like button, subscribe with those notifications on, because that really helps out bump this video up to other viewers, and that really helps out me. So I really do appreciate that. As we become more technologically advanced, more data streams will become even more prevalent. More data is equal to more machine learning algorithms. So it's only a matter of time before we visually start seeing machine learning applications in our everyday lives. But behind the scenes, machine learning is already being applied. Presently, and even in the future, our phones, our emails, even maybe our brains will have machine learning applications associated with them. So let me provide you a brief overview as to what machine learning is and where to begin. First, you need to have a basic understanding of what machine learning is. So you can think of it as this. In the most basic form of machine learning, you have neat, restricted, formulated data in some spreadsheet file. You would want to predict a specific outcome in a given column in that spreadsheet using the other columns in the dataset. Whatever algorithm you will use will minimize or maximize some metric that acts as a backbone for your entire model. These columns, otherwise known as features, can store text or numerical values. Regardless of the type of algorithm you will use, all machine learning algorithms, whether it be regression or classification type algorithms, will attempt to minimize a loss function. Now, there are dozens of loss functions that exist in the data science world, and each loss function is trying to minimize for a very specific value specific to a particular use case. But in order to visually represent what a loss function is trying to do, is that you have, let's say, a predicted value and you have a true value. You want to minimize the distance between those two observations, and the lower the distance is, then the more robust your model will actually become. And let's take a step back and let's define what a regression and a classification type algorithm is. The way to identify whether or not to use a regression type algorithm or a classification type algorithm is that a regression type algorithm is trying to predict real numbers. A classification algorithm is trying to predict categories. So let's say you are configuring a model that predicts stock prices. Stock prices are numerical values theoretically ranging from negative infinity to positive infinity. In the machine learning world, you would typically use a regression algorithm to fit this model. However, if you want to predict whether a person is a good credit risk with the outcome of either being yes or no, then this would be a classification algorithm. And yes, you can configure regression problems into classification problems by categorizing range of numbers in various categories. For instance, maybe you want to buy or sell at a specific threshold or percentile. Machine learning can be flexible and can be grouped into either supervised or unsupervised learning. Now, you might be wondering what unsupervised and supervised learning methods are, and let me break it down for you. Supervised learning is a generalized term to encompass many machine learning algorithms whose dependent variables and outcomes are actually known. So let's talk about weather. For instance, each day has some form of weather pattern. We know that each day at every given second can be sunny, cloudy, rainy, or snowy. Each day will fit into one of these categories at each individual second, and you already know what the general outcome would be. Unsupervised learning is a type of general method that encompasses many machine learning algorithms whose dependent variables are unknown. So technically, you don't really know what you are looking for. You're trying to find suspicious behavior. A great use case here is cybersecurity. Companies, governments, high officials are constantly being targeted, and more often than not, each cybersecurity exploit is a customized script that will find weak points and exploit them. You can check out the AI firm Darktrace, a $2.4 billion company located in London, whose sole purpose is to find such threats. They use unsupervised learning methods to identify suspicious behavior. They don't know what that behavior entails, but they do know that that particular behavior can be suspicious, and that activity can be flagged and placed under review. In the cyber world, known historical exploits are often patched, and the same exploit generally won't work again, thereby making the historical patterns of this behavior in the machine learning world obsolete. And now that you have a general understanding of what machine learning algorithms can be categorized as, let's start building your foundation by knowing what algorithms to learn first and build our foundation from there. And first and foremost, you do not need to be a coding expert. The most important part is actually understanding what those algorithms are outputting, whether it be the statistics, the diagnostics, the feature selection importance, you name it. Those are probably the most important aspects of the entire data science world. Coding comes second. When you become more proficient at understanding how to execute such algorithms, you will by nature become a better coder. So first, you can begin by just perusing through my entire YouTube channel by checking out those videos to build your foundational skill set on what data science could mean to you. The very first algorithm that you should be familiar with is linear regression. Linear regression is just trying to fit a line to your data while minimizing your predicted values with your given true values on that particular data set. Your independent and dependent variables are numerical by nature. This type of algorithm will give you the understanding of what machine learning data should look like and how you should input it into your overall data set. Logistic regression introduces you to the idea of categorization. So you're trying to predict a binary outcome, a multinomial outcome, you name it. So like a yes, no, or if your favorite color is red, green, or blue. You're also introduced to the idea of a confusion matrix, and this is really important because other algorithms use this as to identify whether or not that particular model is robust. This is also when you can start utilizing a mixture of features such as categorical type data or numerical data to predict your dependent variable, where your dependent variable consists of categorical variables. And these are usually one-hot encoded, or it can be just categories on their own, like zeros, ones, twos, or red, greens, yellows, you name it. And then once you understand linear regression and logistic regression, you can get into a little bit more advanced models. So this includes lasso regression, ridge regression, and elastic net regression. This teaches you about penalization of features and how to identify whether or not that particular feature even adds any value to the overall model. You can get into the AIC and BIC codes. You can also get into terms that are essentially squeezed out. And then once you understand the basic idea of penalization of terms, you can then get into factor analysis or principal component analysis, where their primary role here is to identify terms that are completely irrelevant to your overall model and will only add value to the model and won't be a detriment. This provides you a great overview as to how to identify features that are very important via feature selection and looking at feature importance at the relevancy of that specific feature in your overall model. Once you understand the idea of feature importance and feature selection, you will then start to move toward tree-based algorithms. And the tree-based algorithms can be a variation of bagging, boosting, stacking, you name it. But the primary use here is that you'll be introduced to the usage of multi-threading, maybe even potentially GPU usage to maximize the speed time of those particular models, because it actually takes quite a bit of time to run those models if you have a ton of data. you'll also be introduced to the idea of actually applying the confusion matrix, looking at precision scores, F1 scores, you name it. And you will also be introduced to the taste of real machine learning algorithms, because more often than not, these algorithms such as random forest or AdaBoost or XGBoost, these algorithms are incredibly powerful in their predictive power. So once you're familiar with all those supervised learning techniques that I have mentioned earlier, this is probably like a really good situation to get familiar with the unsupervised learning techniques. So a really nice segue to connect the supervised with the unsupervised learning techniques is with K nearest neighbors. K&N can provide you a great understanding of how distances are utilized, especially when it comes to K-means, which is the first unsupervised learning method you should definitely become familiar with. It is probably the go-to unsupervised learning algorithm to be aware of. It utilizes a variety of distances to create clusters in order to essentially categorize similar observations with each other. And once you understand K-means clustering, you can then move on to hierarchical clustering, and then from there go to vector models. And everything essentially utilizes the same idea. You're trying to pinpoint or minimize the distances between clusters or observations. They just use different algorithms associated with it. So if you understand one, you can generally understand what each of the other algorithms are trying to do. And once you have a general understanding of what unsupervised and supervised learning methods are, you can then start getting into the real niche models that have a very specific purpose, or if you have a ton of data associated with them. So I'm talking about neural networks. They have a ton of architecture related to each of these neural nets, and each of these particular neural networks can be used for a very specific use case. You can also go on to utilize natural language processing, which also utilizes some variation of neural networks. You can go to computer vision, that heavily utilizes neural networks there. You can also go to time series. You can also go to genomics. You name it. There's so many subsets of industries that are just vast on their own right, and you can definitely go into each one of these industries if you want to, if you have the foundational skills and understanding of all the previous machine learning algorithms that I have mentioned. Yeah, that pretty much sums it. So if you have all of these tools in your tool belt, you will be really well off in the data science world, since you have a basic understanding and even more so an advanced understanding of how to utilize such methods and how to apply them in your given industry.